from your book. So today we're going to talk about trigonometric functions on the unit circle. And so if you look in your book at the start of section 4.3, this has got an example here. And this is not a problem we're going to work through. This is just something where you can see the trigonometric functions in real life. And so if you look at this, it says a blood pressure of 120/80 measured in millimeters of mercury means that a person's blood pressure oscillates or cycles between 20 millimeters above and below a pressure of 100 millimeters of mercury for a given time t in seconds. A complete cycle of this oscillation takes about 1 second. If the pressure exerted by the blood at time t equals 0.25 seconds is 120 millimeters of mercury, then at time 1.25 seconds, the pressure is also 120 millimeters of mercury. So what that's saying, notice here, it oscillates every 1 second. So if I start here at 0.25 and go to 1.25, that's an oscillation. For those of you that don't know what it means when we oscillate, to oscillate means to do this. Go up and down, up and down. And so basically you have your high point and your low points. You will see that this deals with sine and cosine. And we will get to this when we graph with sine and cosine. And that's the beauty of this, is because it actually relates then to something in the medical profession. Okay. And so let's go ahead and look at the following here. This is taken from your book. It says, let theta be an angle in standard position. So remember, standard position, we start on the positive x-axis. And point P be a point on the terminal side of theta. I don't know if you need to write down all that. It says let R represent the non-zero distance from P to the origin. What is another name for R? Radius. So basically, R is nothing more than the radius. So when you see R, that means radius. That is, let R equal square root of x squared plus y squared equals 0. So let's think about that. Well, you're kind of wondering, what is R? I'm going to draw it up in quadrant 1 because I think it'll be a little easier for you to see. They're telling you, okay, that this is R, correct? Okay, now, I know that I'm in the coordinate plane, and I know I've got a right angle right there. And I know that this distance here is otherwise known as x. Right? Because that's how far you go left or right. I know that this distance here is known as y. And so what they're saying is that since this is a right triangle, I know that x squared plus y squared equals r squared. Because that's the Pythagorean theorem. So then now if I want to solve that for r, I can just take the square root of both sides, and that's going to equal r. And so that's where that statement comes from. That makes sense. So now what we're going to do is, instead of now letting sine, cosine, and tangent be opposite, adjacent, hypotenuse, I'm going to now write these in terms of x and r. So if I look just specifically at this angle right here, theta, and I look at this triangle, sine I know is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. I know that y is my opposite side. What side is x? Adjacent. What side is r? Hypotenuse. So now instead of using opposite, adjacent, hypotenuse, I'm going to use x, y, and r. So in that first example, sine of theta, opposite, which is y, divided by hypotenuse, which is r. Cosine, adjacent over hypotenuse, so x over r. Tangent, y over x. Why can't x be 0? Can't divide by 0, it's undefined. And the same thing goes for cosecant, secant, and cotangent. Questions about that? Do you see where the x, y, and r come from? They don't just dream them up and want you to measure those. Got it? So let's go ahead and look at this. It says let 8, -6 be a point on the terminal side of an angle in standard position. Find the exact values of the 6 trig functions of theta. Okay? So I would just put, like, if you're doing this in your notes, 8, negative 6, find 6 trig functions. Because that's going to give you enough to be able to go ahead and solve this. So the very first thing what you need to do, what do you think?
Draw a graph.
Draw a graph. There you go. So 8, negative 6, what quadrant? 4. So in quadrant 4, I'm going to go 8 to the right, and I'm going to go 6 down. So this right here is the point 8, negative 6. So this side here is 8. Now I'm going to draw my triangle in. This side here is 6, and notice that's a negative 6. And then there is my hypotenuse. So now in order to find sine, cosine, and tangent, I need to know this distance right here. How do you find it? Yep, 8 squared plus negative 6 squared is r squared. So you could do that, or you might be able to recognize this as a Pythagorean triple. Does anybody remember what that hypotenuse will be? 10. It's actually double the 3, 4, 5 triangle. Okay, this would be side 3, 4, that's got to be 5, and you're doubling it. So now we need to find sine. So I've got sine theta, cosine theta, tangent theta. Okay, what goes with sine?
SEC.
CSC.
SEC.
What goes with cosine? SEC. And cotangent.
Cot.
So now, sine. Here's going to be my theta angle. What you could do is you could just label if you wanted. Here's your opposite, here's your adjacent, and here's your hypotenuse.
How do you know which angle to use a theta angle?
Theta is always the angle that touches the x-axis. So now, sine in that triangle will be what, folks? Negative 6 over 10, but you know that that's not going to be acceptable. Negative 3/5. So then that tells you that cosecant is what? Negative 5/3. All right, let's focus on cosine. Cosine is 8 over 10, which is 4/5. So secant is 5/4. Good. Tangent. Negative 6 over 8, which is negative 3/4. So cotangent is negative 4/3. Think you can handle that? So there's the x, y, and r. Basically, what we've already looked at. Okay, next thing I want you to get down are one of those quadrantal angles. I don't know if you necessarily need to write this down because it's kind of one of those things that you'll be like, well, that makes sense. Okay, basically the measures are multiples of pi. When you think of quadrantal angles, they lie on an axis. So they lie on an axis. They're multiples of 90 degrees or multiples of pi over 2. And so our first quadrantal angle is 0. Our next one will be 90. Our next one will be pi. And our next one will be 3 pi over 2. Just a little tidbit of information if I were you. I would start understanding that this is 0. This is pi. Oops, I didn't want to put degrees there.
Wait, you said it lies on the x-axis?
No, the quadrantal angles are always on an axis. Okay, and so this is actually, we know 0 degrees, 90, you know this from previous, 270. Okay, however, we need to shift our thinking a little bit, and we need to now know this in terms of pi. So this would be 0, this is going to be pi over 2, this is going to be pi, and this is going to be 3 pi over 2. So you need to start memorizing the red. Get that down, because the black is not going to be used very often.
That's bad, but that's good.
So anyway, we need to remember 0, pi over 2 pi, and 3 pi over 2. Alrighty, so now what we're going to do is we're going to talk about exact values, and we're going to continue with this tomorrow. What you need to do is you can go ahead and start your homework from this section. We are dealing with page 251. Where you can start is 1 through 8. Okay? On page 251. 1 through 8.